Hi, it's Jakob again, and this is the third example from today's problem set about remainders, and we have some really nasty number, and we have to check if this number can be a square, or actually if it is a square. So what we could do, obviously, is we can square numbers until we sort of go over that number, right? So for example, if someone asks us, is 11 a square? Then we can be like 1 squared 1, 2 squared 2, 3 squared 9, 4 squared 16. Oh, we went above 11 and we didn't hit it. So 11 cannot be a square. We can do that. But that is going to take a long time. So don't do it. We can be a bit smarter, right? We can use remainders. How do we use remainders to find out if something is a square? In general, we can't. But sometimes we can sort of gather evidence, and sometimes evidence will tell us this is for sure not a square, and sometimes evidence will be like, I don't know, and then we have to find another way, right? So how do that? The squares can only have specific reminders, right? And that depends. So we have to pick something. We have to there's no 4 in this problem. I'm just picking 4 because I know the 4 works, right? Because let's look what happens, right? 4 has 4 possible remainders. Any number that you have, any natural number, it can only be 0, 1, 2, or 3 in division by 4. There's no other way. There's no other possibility. The only 4 possibilities, right? And then we know that if we're calculating squares, which is the product of the number of itself, then we can replace that number with its remainder, right? So basically, the only possible remainders that squares can have are squares of those 4, right? So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9, right? And then we transform those into their remainders because they are still, 2 of them are small, but the other 2 are already like 4 or more. So remainder of 4 division by 4 is 0, and the remainder of 9 division by 4 is 1, right? So actually, the only possibilities are 0 and 1. If you square every single number that exists, natural number, and find out its remainder modulo 4, then you'll only ever find zeros and ones, and they will be like 0, 1, 0, 1, 0, 1. Basically, an even number always have a remainder of 0 in division by 4, and an odd number always have a remainder of 1 and division by 4. And we can think about it that way, that if something's even and I square it, then it has at least 2 2's in the prime decomposition. So it is divisible by 2 at least twice. So it is divisible by 4. For 1, it's a bit more tricky, but just squaring the remainders does the job. You can also do it in a more general way by just looking at what happens if you square an odd number. But okay, this is the knowledge that we have, and now what this tells us is that a remainder of a square is a remainder of a square of this remainder, right? So we get the remainder of a square, right? And we need to calculate it, and we calculate the remainder of we can instead of squaring first and then calculating the remainder, we can calculate the remainder first, then square, then calculate the remainder again. So again, this just points what I just said, that only remainders possible are 0 and 1. And that means the number with a remainder 2 or 3 cannot be a square in division by 4. So sometimes, if you think about, can this number be a square, it is useful to look at division by 4 and find out if its remainder is 2 or 3. If it is, then it cannot be a square. Obviously, not every number with a remainder 0 or 1 in division by 4 is a square, because that's like half the numbers, and not half the numbers are squares. But sometimes it is enough, as I said. Right, so again, this is a summary what we just did, and let's look at our big number, right? First of all, this number is very long, so what you do is you say, all right, this is just the first part of the number times 100 plus the rest, right? Why do we do this? Because 100 is 25 times 4, so its remainder in division by 4 is 0. So we can just get rid of it, right? Because we have something times 0, it's a 0, we don't care. We replace 100 with its remainder modulo 4 in division by 4, which is 0, so that means we just get rid of it. It doesn't exist, right? So we just look at 43, and 43 is much easier to calculate because, again, 43 is 4 times 10, 40, plus 3. So we see that this is divisible by 4, so we can just get rid of it, right? So this is 0, and division by 4, and what we left is 3, okay? So in other words, the remainder of this real big number that I don't even remember what it was is 3, right? So like we just said, number of remainder 2 or 3, in this case it's 3, it cannot be a square, right? We can write it as you know, this big number, whatever, 7, all of them, is 4 times something plus 3, right? And that plus 3 tells us that it cannot be a square, right? The remainder is 3, it cannot be a square. We've answered the question. In this case, we're lucky, and we were able to answer the question very quickly. If we found that this number had the remainder 0 or remainder 1, then again, wouldn't mean that it is necessarily a square, but that we would have to find some other way of checking it. And usually it will be like, okay, 4 doesn't work, so let's go to 7, okay? Let's go to 5, let's go to 13. And I go, you know, through the numbers that you can divide things and find if the remainders work. This is how you do it. But this case 4 worked, so we're good. Right, so this is the examples, and I hope you enjoyed the problem set today, and good luck.